Hello guys, today we are going to learn about round robin CPU scheduling in operating system. Okay, so basically it is a very popular algorithm used in time sharing system. Okay, so I will explain it in a simple way with an example. Okay, see, definition. Round robin is a CPU scheduling algorithm where each process is assigned a fixed time slice time quantum in a cyclic order. If a process doesn't finish during its turn, it is preempted and placed at the end of the ready queue. See, so round robin or RR is a CPU scheduling algorithm. Okay, so where every process gets a fixed amount of time called a time quantum to run on the CPU. Okay, so if a process doesn't finish in its turn, the CPU stops it and moves it to the end of the queue. Okay, so the next process can run. So this way all processes get a fair share of CPU time. Okay, now key feature. Time quantum queue, fixed amount of CPU time for each process. Preemptive, process is interrupted if it exceeds the time quantum. Fairness, all processes get a chance to execute. Then ready queue, FIFO, first in first out structure. See, so before we go to the example, here are the main points you should remember. Okay, so see, first, like time quantum, like each process gets a time slice or time quantum. Okay, and preemptive, like RR is preemptive. Okay, so meaning RR is preemptive. So meaning a process can be interrupted if it uses of its time quantum. Okay, then fairness. So the processes are stored in a ready queue in FIFO order. Okay, so it's ready queue. Okay, so it's fair because every process gets a chance to run. Okay, now see example. So see, let's take an example. Suppose we have four processes p1, p2, p3 and p4. So their burst time or the time they need to finish are like, see, p1 is p1 is 10 units. Okay, p1 is 10 units, p2 is 4 units, p3 is 5 units and p4 is 3 units. Okay, so we choose a time quantum of 3 units. Okay, so now let's see how the CPU runs these processes. Okay, so basically p1 runs for 3 units. Okay, so it still needs 7 more units, so it goes to the end of the queue. Okay, then p2 runs for 3 units. Okay, so it still needs 1 more unit, so it moves to the end. Then p3. Okay, so p3 runs for 3 units, remaining 2 units goes to the end. Then p4. So p4 runs for 3 units, it finishes completely, so it leaves the queue. Okay, so now the queue has p1, p2 and p3 again. Okay, now see, p1 runs for 3 units, so remaining 4 units. Okay, remaining is 4 units. Then p2, P2 runs for 1 unit and finishes. Then P3. P3 runs for 2 units and finishes. Then P1. P1 runs for the remaining 4 units and finishes. So and now all like processes are completed. So now see, if you draw the timeline, it looks like this. See, P1, then P2, then P3, then P4, then P1, then P2. See, P1, then P2, then P3, P4. Again P1, P2, P3, P1. It's okay. So you can see that each process gets the CPU time repeatedly until it finishes. So this is the essence of like round robin scheduling. Okay. Now see advantages. Fair CPU allocation for all processes reduces response time in interactive systems, simple to implement. See, basically fair to all processes, reduces waiting time for interactive systems, easy to implement. Now see disadvantages. Time quantum selection is crucial. Too large behaves like FCFS. Too small high context switching overhead. Not ideal for processes with highly varying burst times. See, choosing the right time quantum is very important. Okay, so too large for behaves like first come first serve. Okay, FCFS means first come first serve. Okay, then too small like cause too many context switches. Okay, so round robin is great for like time sharing systems. Okay, time sharing systems. Okay, where we want everyone to get CPU time equally. Okay, the summary is round robin scheduling is primitive, cyclic, and fair, making it ideal for time sharing systems. Every process gets a fixed CPU slice until all process finish. Okay. Okay, so basically round robin round robin algorithm is like widely used in time sharing systems. Okay, so where multiple processes share the CPU fairly. Okay, and round robin is a preemptive CPU scheduling algorithm. Okay, so this means every process gets a fixed amount of CPU time called a time quantum. Okay, so if like process doesn't finish in its time quantum, so the CPU stops it and moves it to the end of the ready queue. Okay, then the next process in line gets CPU time. Okay, so this always all process gets a fair chance to use the CPU without waiting too long. Okay, and key points are, first one is time quantum, preemption, ready queue, fairness. First one is time quantum. Each process gets a like fixed amount of CPU time. Then preemption. So basically process can be interrupted after using its time quantum. Then ready queue. So the process are stored in a queue in FIFO order. Okay, then fairness, every process gets CPU time repeatedly until it finishes. Okay, so basically if we like choose the time quantum wisely, so round robin works very efficiently. Okay, so basically round robin scheduling is a preemptive, cyclic, and fair CPU scheduling. Okay, so each process gets a fixed time quantum and the CPU cycles through the queue until all processes are finished. Okay, so basically it's like simple, effective, and widely used in systems where all process need to share CPU time fairly, like in time sharing systems. Okay, so that's it for today's lesson. Okay, thank you.